Hi, everyone. Thanks for joining us for another episode of N08 Answers. Today, we're going to cover a topic I think there's a whole lot of interest in. We're going to discuss real lessons from AI native development. And we've got a couple of special team members from the N08 team that are joining us today for the conversation. So we'll just dive right in.
What is the biggest change that was unexpected for you as AI has come to be a core part of your ideation and development process? Not just like what's been the biggest change, but like what kind of surprised you how much AI has impacted the way you do your job?
What we're finding is that the impact of using AI and these a lot of these AI tools in certain stacks, we're seeing obvious impact, and the degree of impact is much different at depending on what stage of the product you're in. So for example, really early product, getting from nothing to like a prototype is like incredibly like more effective than it used to be. Huge lift, right? Getting from a proof of concept to something that could be considered an MVP or maybe an early release candidate, we're seeing big lift there. And we do see a lot of impact from ongoing development, but it's not right now to the degree of like an efficiency gain that we're seeing really early in the life cycle.
I have been around for a long time, and I think that led me to a certain degree of skepticism, especially asking, how can a giant pile of linear algebra do what we normally had an engineer or an architect or any number of roles do? And I'm a little bit chastened by the answers there. I'm going to start. I'm going to start just by mentioning that I think when you talk about how processes change, right? I think that's at the heart of what we're talking about. There's almost a sense as we use AI, as we use generative AI, code gen, in our projects, it's not necessarily that we're able to take like a 3-story point task and turn it into a 1-story point task. When you get down to this very granular level where I was sort of expecting to see a lot more immediate benefits, right? And we see that in sort of like autocomplete and IDEs and things, and that's great. But at the very granular level, I don't think we see the same sort of acceleration that I would have thought. Instead, we see it at a higher level. And Jeff, when you talk about the way that sort of AI code gen has enabled us to move to prototype much faster, it enables us to basically take large lumps of work that normally we might not have done in the same way or even necessarily done at all. And suddenly AI makes that very easy. So one thing that I think is interesting is that, we're not seeing AI so much in the productivity statistics, and academic articles kind of back that up, right? When they look down at the task level, developers are not any faster at a task level with AI. Sometimes they're slower at task level with AI. But when you look at our experience, real world experience within the context of a larger project, there's entire parts of that project that wouldn't have been done the same way, might not have been done at all, but suddenly we can execute them very easily. So that was a bit of a surprise. I think I was expecting to see, a little more of AI acting as a true kind of other developer on the team. And instead, what we're really seeing is that it's acting as a very different kind of resource inside our environment.
What is something that we would do perhaps differently now because it's so much faster to just do it that way, where it would have been maybe very labor intensive in the past? Like, what comes to mind when you think of that type of example?
Sure, great example. And I think something that is really at the heart of what N08 does is that there's a whole realm of kind of that upfront design thinking effort that traditionally, if we were working with a client, bringing a new product to market, working on an existing process and building new technologies or experiences around that, normally during that design effort, we'd be focused very much on kind of traditional UI design, wireframes, the sort of interactive or clickable prototypes where we're using existing tools, Sketch and Figma and things like that. But we would have shied away from trying more end-to-end technical prototypes.
Okay.
And that's been, that's true with a mid-sized firm like Enowate. That's true with very large agencies that I've been with. Those sorts of like true technical prototypes, we always tried in the past to make them very, very limited, right? We're going to do a quick proof of concept to show something, reduce some risk. But all of a sudden with AI, it's very cheap and very easy to build end-to-end prototypes that let us very quickly validate hypotheses in the market. And, I think this is a great example. We've seen clients show up with, kind of vibe coded solutions, some of which serve to kind of act almost more as a UI prototype. And in some cases, coming in with something that actually, not go to market ready as such, but certainly further along than we would normally see. And it lets us iterate faster. So there's a lot more, proving that kind of end-to-end technical to interaction solution that normally just wouldn't have been possible, right? I mean, we would commit developers for weeks to do that. And suddenly we're collapsing that down to hours.
I think that right there is a theme that we're seeing all over the process. Like for example, I've in the past, Andrew, we've done a lot of these N08 answers, and I've talked many times about one of my favorite artifacts is like a Figma design prototype, right? That's not my opinion today. Like that's changed from a year ago. And part of the reason why I liked the design prototype as an effort to get clarity around what we're actually going to build is because the effort was so much less to work on screen designs, like wire it up so you can click through it and simulate the experience and share it with people, get feedback, that kind of thing. That effort was so much lower than building something. Well, that whole math has changed now, right? Like we can go from concept into an actual prototype build faster than we could probably custom design a clickable prototype. In fact, probably much faster. And so I think that right there, that's an example, but we're seeing that across the whole life cycle in every part of the product development process. So we have a startup company that came to us with a pretty detailed requirement document. And because of a lot of the internal work that we've done, we felt very confident that we could do this drastically like faster and more cost effective to get this startup from like basically a vision to a working MVP that they can start going and validating with. And that project would have typically been, we do an innovation lab up front, 6 weeks of work, in most cases where we're doing all kinds of activity to just define what we're doing, right? And instead of a 6-week innovation lab followed by, probably a couple of month development effort, we felt confident that we can get them an MVP inside of 8 weeks, basically, at a budget that is competitive with what we would have been looking at before just to do design work and all the definition and technical design, all the upfront innovation lab stuff. And so that's pretty compelling, right? And it's not this concept of like the quote vibe code, right? Because I think one of the things that we know very clearly based on our experience is that it starts with having very competent expert people that we also needed in sort of the old process, right? But those people armed and trained and capable with this sort of AI tool stack, it's insanely more efficient and fast, and you can just build better products that way. So that's a really good example where we're seeing really hard impact on speed and efficiency and, what the even team configuration is for it.
In a situation like that, though, are you just kind of like throwing a lot of stuff at the wall very, very quickly and then iterating and finding what sticks? Or are you finding that the like strategy definition piece of it is as important or maybe more important than it was before because the speed to development or speed to prototype is so much faster?
It's a good question because the importance of clarity is is still important, perhaps even way more important, right? Because AI can get you somewhere really rapidly, but what good is that if you don't end up in the right spot, right? And so but again, how do we create that clarity? That process is evolving really rapidly too. Like we can do that even faster, better now because of some of the tools that are available, and not just that the tools are available. It's about understanding what is the right tool for what part of the process and what's the right collection of tools, which changes literally every single week almost, it feels like. And so I think like it's almost a whole other secondary capability that guys like Craig and Maximus are having to build, of AI competency on top of software development and engineering competency.
You make an interesting point. You ask about, the difference between kind of throwing a lot of stuff at the wall and, trying to find what works and iterating on it versus being very precise. And I think one of the things that sort of a helpful conceptual lens when thinking about AI is that AI is not a person. AI does not reason. And when you have the quote unquote reasoning AI, like some of the GPT versions, if you ever look at the raw reasoning, what they call reasoning traces, it's really opaque and impenetrable to a human. These are not thinking machines. AI is, one of the kind of metaphors that I use about it is it's a thought amplifier. What you put in to a generative AI, to any kind of generative model, what you put in, you get back out just amplified, magnified. And so consequently, the less precise you are going in, you are going to get more out, and it is going to be very imprecise. It's going to be very fuzzy. It is probably going to be wrong in lots and lots of ways. And so, AI does not replace, and to Jeff's point here, right? Like AI does not replace programmers. And I don't think that we see a world where, to be honest, we lose a lot of developers. I think that the sort of disruptive impact of AI on personnel has been oversold. And I think we've seen companies that went down that road, they're starting to they're starting to haul back and realizing, no, we're not losing the need for personnel, but personnel are operating differently.
Mm-hmm.
And that brings some interesting problems that we can talk about kind of later in terms of, how do you build a skill set around that. But, kind of the main thing that I think that we've seen is that to be successful, you have to be precise going in. You have to have a technical view. And so what you get back out is magnified, it's amplified, but the edges are very, very sharp. When customers have come in with kind of their own coded solutions, and we're seeing more and more of that, right? The more technical they are, not even necessarily, computer science, but the more technical they are in their own profession and the more precise their understanding of the domain that they're operating in, the better the outcome. The closer it is that it's something that we can pick up and continue to iterate on. Whereas if somebody comes in without that same lens, if they're a little bit fuzzy on what they want, or they don't have a very, kind of engineering-centric mindset of some sort, then what we see is something where we can kind of look at it and say, great, this gives us an idea of where you're going. But if you look at the back end, if you look at the way, the AI has assembled a database, the way the code is structured, we're like, yeah, that's really not going to work. So it is an interesting question of, vibe coding tends to throw a lot of stuff at the wall and you hope for the best and try to iterate on what works. But a much more effective way to do it, and Maximus would love to have you kind of go through this in some detail because I think you do this really well, is to be kind of laser sharp on what you're trying to get out of it, let it magnify that back, and then iterate on that before going forward. And I think what we've seen there is you can actually generate code that, I wouldn't characterize it as truly production ready, but it is a scaffold upon which you can continue to build. And that's a place where we do see efficiencies, unquestionably.
We're sort of seeing this potential that AI is going to return us to a little bit of a waterfall style approach, in that we try to define a better spec up front. So there's like sort of this concept of spec driven development. So we know that if you try to hop in with a tool and say, build me an app like Uber, right? You're going to get garbage. But if you first develop a really thorough spec, which you can do in a fraction of the time now, that's really baked out, and you have experts reviewing as that spec's coming together, people like Craig viewing the database schema and the architecture, that kind of stuff, right? To help make sure the spec's really good, then now you can run with that spec and stand something up a lot faster. You don't have to wait months to build it and hope that you got the spec right, which was the big problem with waterfall, I think. So Maximus, like, if you can talk a little bit sort of hands-on, in terms of setting up an initial project and what you've learned, just give us some general thoughts on, where you're at today in terms of what you ideally like to be able to start with minimally, and sort of some of the setup stuff, and maybe even how has that evolved from, maybe a few months ago even.
Of course. So the first thing I will say is typically, let's say a client offers an MVP, and it's typically something vibe coded that works well enough to just demonstrate the purpose of that project, but it's kind of like an iceberg where you really could not develop it into a production level app. What I would do is I would take, let's say if they had a requirements document or any other sort of document, I would condense that, and in a development workflow, I would start with a context folder. And in that context folder, really what I'm trying to do is make blueprints for that project. And then in those blueprints, I may phase out plan by having a spec for the whole code base, the whole system design. And obviously some parts of the code base can only come after others. So I can't do all too much with the front end before I have some things for the back end. And I can't really start on the back end before I have things done with the database. So one thing I would say here is that it's generally better to silo off tasks to the AI and clearly defined guardrails so that it doesn't go out of bounds, it doesn't do anything crazy, and most importantly, it doesn't accidentally delete your code base, which does happen. You do need to have a tight leash, because if you're not careful, it will do a lot of damage.
It sounds like you've
Especially,
experienced that.
I've been fortunate enough not to have like an entire production database deleted, but I have seen it just completely wreck like several parts of important code base without really me realizing it, which leads over to another point about what we call vibe coding, and I think eventually it would just be called delegation because that's what we're doing. We're usually just delegating an AI agent to go out, work on a problem, and then we review the output. Is that if you're not careful, if you don't read the output that goes into it, um, you could be down for really, really bad weekend. Like, it might blow up the code base in your face before. That part has happened a few times. But um, with spec-driven development, again, another thing too is that it's been very helpful to look at it in terminology of project management, in that you're not really just having some chat session with, let's say, Cursor or Claude Code and say, great, after this feature, I want you to work on this feature. And I'll just type in like a few words saying like, please add this feature and that. I typically have a back and forth conversation, mostly about engineering considerations, about something I'm about to work on before I write it into some sort of plan file that then I delegate the AI agent to.
And I think that's a really, I think that brings up some really interesting aspects around how this changes the process. Because there's a couple of things that are kind of really quite alien, I think, to traditional software development, and a few others that we're hypothesizing. We're, as Jeff said, check back in a couple of weeks and we'll tell you how this goes. The first one, I think, Maximus, the point that you make is that there's a certain degree, just by the nature of the technology, a degree of chaos that is injected into these projects. I mean, that's one of the phrases that I've used now for almost a decade when it comes to generative AI, since really the early days pre large language model, is that AI is sort of approximately wrong. It's not right. It's never right. It's always wrong because it doesn't think, it doesn't reason, right? It's a compressed, in LLM's case, it's a compressed representation of human knowledge in about 8 gigabytes of weight. It'd be insane to think that it could be right about anything, but it's wrong in really helpful ways. And so, finding the ways in which, it is helpfully wrong is the big challenge. And, from our standpoint, again, for, the last 7-8 years, we're coming out of kind of, big tech where we were trying to make use of earlier versions of this. My operating hypothesis has been for several years that the big challenge is to take these approximately wrong, kind of stochastic, chaotic systems and to fit them in processes where our traditional assumption has been that a human being is doing it and is doing it correctly, right? Our traditional processes are catch the exceptions that come out the other side, whether that's something like total quality management with Deming, which is a sort of statistical review of products coming out, or agile QA in software. We assume that things pretty much work, and we're trying to find cases in which they don't work. With AI, you kind of have to assume it's not going to work, and you have to exhaustively test everything you want to find out where it does work. And that's really interesting. It's really quite inverse to the way that we normally think of it. And I think one of the learnings that we've had recently as we've gone forward with this is the role of QA, which has always been critical, always been foundational, is oftentimes, especially by software developers, not project managers, but by software developers, overlooked, right? QA are the folks who tell me my code is wrong. I don't like that. But we've really created an environment with AI where we need QA even really before the beginning of the project. Traditionally, if I'm doing a large project, I roll QA on after sprint 0. And generally it's a staggered roll on, right? The first sprint, we have some QA come on and then more the next and the next and the next. Partially because traditionally, we have database, back end, front end, and we're rolling them on staggered. With AI, everything kind of comes on much, much faster. And we need QA really from even before the code is written. We need QA to know what the code is supposed to do and to be able to build those tests. QA becomes foundational because we have to understand, the developers go in after the fact and try to understand the logic behind what's been written, but we have to understand what's the output. And so that's really interesting and really unusual. So anyway, that would be kind of one of the major sort of processual changes that I think are sort of non-obvious until you're in the thick of it and you're trying to figure out, what is this thing generating?
One of the things that I'm curious about is, at least from the tools that I've used, it seems relatively clear that certain models, certain companies, certain tools are better for certain tasks. So one of the things I'm very curious about, and obviously, as Jeff said already, check back in 2 weeks, it could be totally different. But as of right now, what are you seeing in terms of, or what are you using in your tool stack when you are putting AI agents or putting AI tools to work in our design, delivery, prototyping process, all that good stuff?
I use several, and I use several because I don't want to be attached to any single one of them because it is a very hot competitive space, which is constantly changing. But typically for a project, I would use either Cursor or Claude Code. They're both good for their own different reasons. When it comes to just having a quick generation of what a website would look like for an MVP, I may use Lovable or may use some other tools, specifically designed for generating websites. Don't be too attached to any of these tools because they always change.
What do you like about Claude Code or Cursor? Can you kind of talk about those two specific? Because those are ones that get talked about a lot. So why do you like one? Why do you like the other one? Like what's kind of your pros and cons of each?
So Cursor is kind of like a Swiss Army knife. It is a fork of VS Code. So you have a code editor where you can see the code. You can write code manually yourself, which people surprisingly still do nowadays. And you can have autocomplete as one feature. Although typically what people do is they'll have a right pane of the screen where they have a chatbot, and in that there's a lot going on there. That's sort of the bread and butter of Cursor.
Mm-hmm.
You can sort of delegate it to write down, code for you on like a basic task. You can use a plan mode, something similar to spec-driven development earlier, which a lot of these AI coding tools now are beginning to embrace. Or you can do some other stuff, like you can go into settings, you can index documentation for code base, and then you can reference that. That might sound a little bit specific, a little bit technical, but it is one of those marginal features that adds a ton of value. Because if you're a developer, if you're trying to work with projects, you're typically going to use libraries, you're typically going to use code made by other people. And the best way you can present that information to the AI is the best possible outcome. Now, for Claude Code, it is engineered, I would say, to be willing to burn as much tokens as possible. They try to brute force their approach to solving a coding problem for you. So with Cursor, and one thing I don't like too much about them is that in terms of pricing, they have an incentive to try to keep a quote unquote unlimited pricing or a limited token usage AI requests under like $20 a month, $50 a month, which isn't realistic. And typically what they have to do is they'll let you use the most performing models most of the time, but in the background, they'll try to water down as much as possible to try to reroute you to like a smaller, less powerful model so that they could save on costs. Claude Code doesn't do that. If you don't have the Claude Pro 20x whatever plan, a lot of these companies are bad at naming.
Yes, they are.
Really bad. You just pay by the token, so you just pay for what you use, and that can get pretty expensive pretty quickly. So one thing there that Anthropic, the company behind Claude, the model, Claude Code, is with that subscription I mentioned, it's Claude Pro 20 at SMATs. I think that's the name. I'm correct. Is that for $200 a month, you also get a quote unquote unlimited usage. But the caveat there is that while they don't try to water down the model for you, you have this arbitrary weekly limit that just pops up out of nowhere. So these tools are great, but as long as you're aware of the shortcomings they have, which is typically with pricing, because this is a new field, figuring out how to monetize these extremely powerful tools is still being figured out. Um, I think someone could have a great experience working with these, no matter the level of technical experience they're at. If they're just a beginner, they could definitely spin up an interesting looking prototype. But if they want to go further along and try to make a product that people actually use and can actually run, stable, you're definitely going to need more experience. I'd say, generally speaking, to add on to what we were discussing earlier, is your output is your input, and you can only go really as far with AI coding tools as your experience is. So if you happen to not know much about working with databases, you're kind of limited. You're going to hit a ceiling when it comes to using these AI coding tools with what you'll end up seeing with a database.
Yeah, good point.
Yeah, what like two of my favorite quotes that keep kind of like banging around my head around this is that speed is only useful if it's in the correct direction, right? Like if you're going really fast in the wrong way, then it's just going to take you that much time to get
Further
back
away.
to zero before you actually start going the right way.
Yeah.
Which like obviously here is that like AI, the phrase that I've kind of liken to, Craig, is that AI is a force multiplier. Be sure you're multiplying the right thing, right? Like it will multiply whatever you put into it, like whatever you feed it, whatever you ask of it, like it will multiply that. It will do it faster. It's an accelerant. But if you're pointing it in the wrong direction, then you're no better off, and sometimes you're worse off because like you've gone a long way very quickly in the wrong direction. So
Yeah, that's absolutely true. And I think that goes back to, when Maximus, when he was talking about how he kind of carefully slices the increments of work, right? Okay, before we can get to the front end, we have to work on the back end. Before we get to the back end, we have to work on the database, right? I mean, to a software developer, that's very intuitive. I think to a lot of people who are using these tools, that's not really their background, and so they end up trying to do too many things in parallel. And what happens is it becomes hopelessly entangled.
Mhm.
And so absolutely, it is a force multiplier, and the problem is it chooses what it wants to multiply. And so if
Yeah.
you're not very precise, that may not be what you want.
well, I
You know,
also
Craig,
have to imagine
I think
too.
there's something about that might be worth drilling in a little bit, because the like a tool like a Cursor or a Lovable in the hands of somebody who doesn't have experience building products, right? They can get out of the gate and really far, really fast, but
Mhm.
it is almost certain they are either one of two things. They're going to hit a wall, like they get to 80% and they cannot get to 100% of what they're trying to do, right? They end up like running in circles. And while they're doing that, there's all kinds of stuff that they don't really know what they're looking at going on sort of underneath the hood, right? The big ones that people think about are big security vulnerabilities. We've seen that in like vibe coded products. We've seen like gaping security holes that you seriously would not want to have in production. Somebody who doesn't know what they're looking at, they're not going to know what to look for, or that's a serious problem, right? And we've seen the headlines about that kind of stuff, right? And so I think, if I'm speaking to folks that are like maybe more like a founder or, product owner inside of a large organization that's trying to get something down the road and get people to buy in on it, don't underestimate the need to have somebody with real expertise involved in reviewing it, either early on, which is better, or definitely as you get later in the project. And don't expect that when they look at it, they find really big problems and they need to sort of backtrack and maybe refactor or clean some stuff up or correct some things. That should be expected, right? If you're not giving it the right instructions, like your input is your output, if you're looking at something going, hey, make this secure, the AI is just going to throw up its hands, right? So you have to be able to be very specific and give instructions to it. And we've seen when we do that, it's pretty eye-popping. And we've been surprised a lot over the last several months of like, man, I did not expect it to be able to do that so well, so fast. But the observation was, but I saw what the problem was, and I was able to give it like some very specific directions and guidance on what changes we want to have done.
Right. I think one of the things that's really, really interesting and maybe not surprising, but very telling, is if you minimize the number of tools in your stack, the better the AI is going to be able to reason, right? You're lifting the complexity out of the AI and into services that you import in. And a great example is, we've now had a couple of these projects where the back end is a product called Superbase. And Superbase is basically an open source version of Firebase, but it integrates a database, it integrates an API surface, it integrates authentication and security, and everything is kind of within this one package. And so it's very, from a surface area perspective, it's very compact for the AI to keep in state. There are diminishing returns to context size. AI companies, OpenAI and Anthropic and the like, bet very heavily, Grok bet very heavily, XAI, on increasing the context size to very, very large amounts, right? Be it the ability to put a huge amount of text into the working memory of the AI. And what they found is that you don't get linear responses to that after a while. You start to see actually from diminishing returns to negative returns, because it's harder for the AI to keep track of what's important, right? The attention heads start to get maybe scrambled a bit. And so the more you can sort of reduce that surface area, the safer you're going to be. If you want a secure product, something like Superbase is really quite ideal because the AI doesn't have to reason about security. A lot of that is already baked into the API at a fundamental level, and it just has to reason about that. If we're getting a more complex sort of environment, a lot more custom development, then we have to start asking ourselves, how do we ensure that we can sort of minimize that context load for the API? And that, I think, is interesting. That is a great example of check back in a few weeks, we can tell you more. But one of our hypotheses is that we need to think about the design of these systems in a slightly different way, and in a bit of a surprising way. There's been a move in recent years, especially as companies sort of hit the limits of proliferating microservices, right? Very decoupled architectures. They're like, man, it's really hard to run a small to medium-sized business when I've got 250 microservices and a bunch of Kubernetes control planes. And, it's too much. It's too much. We want to bring everything back in. And one of the ways that, we do that normally is we start with what's called a monorepo. We take all of our Git repos and we try to turn it into a compact code surface so you can bring all that down. That is the worst thing for an AI. It operates off kind of the basis of the Git repo that it happens to live under at any given point. And if you give it a mono repo, it's too much code. You're having to manually swap things in and out. And so one of the hypotheses that we have is that because AI can be a force multiplier on things like generating infrastructure as code scripts, right? I don't necessarily, it doesn't indemnify me from being able to read Terraform and understand some of that. But, I can offload at least a first cut off to an AI and have it own some of that, which would, sometimes be a lot more arduous. And what that means, I think, is that there are certain architectures that I would not have recommended for small companies, medium-sized companies, many large companies even. And that is the kind of architecture that I kind of lived and breathed in kind of big tech solution architecture. Lots of microservices, lots of decoupling, lots of asynchronous executions. The reason that we would do that, if you look at like a, large company type projects, we would recommend those architectures not because they were necessarily, to be blunt, the best technical architecture. A lot of times, you would go forward with that, even knowing that you don't need that kind of scaling, right? We're not making Netflix. We're not making Google. We don't need, hugely scalable microservices. But we were solving for organizational problems. Our problem was, I'm going to roll 120 developers onto this project, and I can't have them working on a monolith. I can't have them stepping over each other. So every team gets a microservice or a set of microservices. And we define as part of the solution the code contracts, the API surfaces, how they're communicating, what they're supposed to do. And so I can throw a junior developer on the other side of the world into the project. And within a couple of days, they should be able to start being productive because they're operating on a really bounded area. Turns out that organizational problem looks a lot like AI development. I have essentially an infinite number of AI agents I can spin up and I can send out to do things. But I really need to limit what they're working on at a given point. One of the things that Maximus said in one of our internal meetings, I think really stuck with me and really kind of led me to reconceptualize things. Sometimes it's easier just to tell the AI to blow everything up and rebuild it than it is to try and fix. And that's fascinating. That is so alien because in software development traditionally, right?
It's a scary statement to hear. You're like, what?
Exactly, right? Every line of code is precious in traditional software development, right? Yep. If you're going to write it, you want to know why you're writing it. You want to know what it's doing. You want to, ideally you're taking code away, not rebuilding it. Every developer wants to rebuild the code they've been given, but to realize that, wait, no, actually it is cheaper. With an AI, every line of code is cheap. Every, second of developer attention is expensive. And so all of a sudden, it's a very different way of looking at things. And it's a way of looking at things that is a lot more focused, as Jeff said earlier, on almost more of a waterfall approach, right? We're getting back to things. I mean, I'm old. I've seen multiple versions of this, right? We had fourth generation languages. We had a whole realm industry in the 1990s, early 2000s with products like Rational Rose, where you were supposed to be able to draw your data model and generate all the code from it, right? In a lot of ways, this is very similar to that. It has the same promises, and it probably has the same shortfalls. But that doesn't mean that it's not valuable, and it doesn't mean that we can't learn lessons from those previous attempts and use them here. And so when we talk about schema-driven development, it really looks very familiar to a lot of enterprise development that I saw in the 1990s and early 2000s. I think the lessons are there. And the lesson really is that, you need to really exhaustively define your solution and then start drawing boundaries around every part of that solution. Because we're going to let essentially a junior programmer loose on it and repeat that, an infinite number of times in parallel. But the less they have to know and the more you give them those guardrails to code around, here's what the function should look like. Here's your API surface for authentication. Here's your logging, right? Don't reinvent any of this. We're going to define this up front. Here are your data models. I've had excellent response where I go in and do the database work and then give the SQL DDL, the database description, to the AI and say, okay, I need a bunch of CRUD APIs, right? This is something that would take me weeks normally to wire up. I'm going to build, I've got 100 data objects. I've got 4 to 6 API endpoints for every single data object. They interrelate. I've already written the SQL for this. Just wire it up for me. And it can do that very, very well. It can do that very effectively and create a lot of efficiencies there.
Context is a really big issue right now. Like, how do you handle it? How do you manage it? How do you expand it? Should you expand it? What happens when you expand it? Does that actually solve the problem? And some of the feedback from Craig there kind of indicates that just expanding it doesn't necessarily solve the problem. And it sort of leads to these decisions around fundamentally, how do we actually go at a project? How would we architect it, right? Like, we're considering architectures for products now that we would have never looked at that approach a year ago, but it makes sense now because all the math is different, right?
In AI engineering, this is called context rot. That's the term
Context
given
rot.
by people. And it's just giving it more information than it needs. It's not that much different than like if you're onboarding someone new, a human, since I need to clarify that nowadays. You're onboarding a human and you give him like 300 pages of information so that he can do absolutely everything perfectly instead of just giving him like 10 to 20 pages of like everything he just needs to know. And then anything that's sort of an exception, he can ask you or ask some supervisor about. So one thing I would add on top of what Craig said earlier is that generating tokens, so the AI generating code, is cheap. It might be a little bit pricey if you do too much of it, but what's really expensive is understanding and then being able to take that understanding and put it into writing, wherever it may be. It may be in a document, it may be in a conversation, typically a document. And that's something I've noticed above anything else is that as long as you minimize the surface, the blast radius of what the AI has, you can actually move a lot faster because it's more like a long series of small pragmatic steps than it is you like taking 2 or 3 big jumps. It's more like taking 1,000 smaller steps along the way so that you have a chance to be able to backtrack, minimizing as much damage as you possibly have. So, and as for guardrails, the simplest possible guardrail is the very human who's reviewing the code from the AI. And that might be, you let it run for a little bit, you let it work on like a feature or some delegated task, and you don't really like the code, you don't really like how it tried refactoring something, you don't ask it to refactor. So what's great about Cursor, for example, is they have a checkpointing feature. You can just roll back that checkpoint and start again. It might cost you a little bit extra money since you may be charged by the token, but it'll save you a lot of time. a lot of time, hours even. So that's probably the biggest takeaway above anything else for me, is that it comes down to making sure you're giving it just the right information, it has just the right surface area, and it has really the most pragmatic approach to building this. Because another thing too that Craig said earlier is that some people might not know when to start with like a database and then move on to a front end. And that's something that's probably an advantage for the more techie people out there, is that it's kind of like building a house. You can't really start with the framing and you can't really start with the HVAC before you even have a foundation built. So that's another thing entirely, which is that you need to know how a project progresses over time before you can really reach the fullness of that project. Otherwise, for a beginner, at best, they'll just experience diminishing returns if they're working on a project that starts with an MVP and they try to push it out to something more production ready. And at worst, and honestly more likely, they're going to have what are called foot guns in programmer circles, which is basically taking a shotgun and blowing your foot off.
You are not excused from knowledge just because you're using AI.
That's right.
The Google paper that kind of started the LLM revolution was called "Attention is All You Need." And when we start talking about context, the less directed that attention, the worse the results are. There are sort of two things that AIs do, LLMs. They generate data from their sort of intrinsic trained knowledge, right? That lossy, compressed representation of all human text. Or they operate on the text that is sitting in their context. And, ultimately we want kind of a combination of that, right? We're not going to put, here's how to write C, here's how to write Go, here's how to write a React web application in the context. We want that to come out of that lossy representation, but we have to guide it with what's in that context, which is, again, the magnification issue, right? What is in the context gets magnified, and you want to maximize the amount of value there, and you want to minimize or very, very carefully constrain and corral the data that's coming out of that lossy representation, the fundamental trained model. How you test and validate the creation, right? Traditionally, Agile, we talk about things like test-driven development. I'm going to write all my tests. They're all going to fail because I have no code. And I, as a developer, I'm going to write code and my test will pass. And I will write more code and my next test will pass. And I will, I use that to sort of, scope my work. Here's all the tests I need. This is the ideal version. But, ideally speaking, I'm going to write all my tests and then I'm going to write code and all my tests will pass and then I will be done. Instead of test-driven development, AI is error-driven development. I'm going to have these tests and I'm going to throw code at it and they're going to blow up. And that's how I know what doesn't work. I'm not starting with all my tests fail and then I know that my tests are good and good and good. It's really the opposite, right? I'm setting sort of like a field of mousetraps, and the ones that go off, I know that's where the AI got it wrong. It's a very strange way of looking at development because it sort of presupposes a kind of opacity to the code that's being created, right? You generate the code and then you see what it does, and then you try to understand it, right? But the first step is not understand the code and then see what it does, which is a traditional kind of approach. The first one is run the code, see what happens, and then you go in and try and figure out, okay, what did it build? Why did it build it? And it's a very, I'm not going to say backwards, but it's a bit of an inverted approach.
It's very alien. It's very intuitively unintuitive. That was actually something I was going to say earlier about the generating code is cheap, but understanding is expensive. Now, when it comes to understanding code, sometimes I've done this before. I don't always do it, but I'll confess. Sometimes I'll even delegate the very understanding of code to another AI just to write me a summary of the code base. That happens before, especially if you end up generating tens and tens of thousands of lines, is that sometimes you just want to summarize it. It's kind of like breaking it down into like some sort of search algorithm so that you can detect where there may be problems in one area compared to another area. And a tool for that's really helpful is DeepWiki, which even it doesn't matter if it's a private or public code base, you can just paste Simmons like a GitHub repo. You can paste that GitHub repo into DeepWiki, index your code base, and it makes this very beautiful, collection of documents that describes the architecture of the code base. One thing to go back onto is that it's a little bit like exercise when it comes to error-driven development, is that you want to push towards failure. You want to push it as much as you can. You want to try to, not necessarily reps, but you want to push towards failure so that you have a better idea. It's sort of exercising like your, I guess you could call it an AI wrangler muscle or your skill set, which you want to see how far can you push this model until it starts to break down. It starts to have depreciating returns, which is another thing about something I've talked about of like a threshold of complexity, is that you want to figure out what are the limits really for these AI models? Like just how much complexity can they handle, even if it's discouraged to try to push for complexity? Because it helps you better understand um, a more complete landscape of what you can do with these AIs compared to what you cannot do.
There are certain ways in which this kind of AI-driven development has some similarities, even though it's absolutely nothing like quantum computing.
Okay.
And it in the sense of, from Maximus's insight that tokens are cheap, understanding is expensive.
Yeah.
The reason you do sort of this error-driven development is because you are essentially attempting to, in a really incorrect way here, but trying to converge all of this generated code in kind of the lowest energy state, right? If you're doing quantum computing, every time you do something, you're really setting up a little scientific experiment, and you want all of your answers to be kind of the lowest energy state that everything is going to kind of converge on and stay stable on. And one of the ways with AI development is you bound that context into something as small as possible, build a lot of tests around it, and then just keep hammering it. Generate the code, see what works, try to improve that. If you get to a point of sort of complexity collapse, then maybe you pull back and you start again. But it's really in an environment where you essentially, before you really try to understand what's going on, you try to sort of recursively generate as much as you can to satisfy as many tests as you can. And then when you get to that point, you're like, okay, let me understand what's going on. And then you go back to the iteration side. And, Jeff, we've talked about the way that you use ChatGPT, which is as a kind of recursive and reflective process, right? You sort of, you're talking to it, you're focusing on certain things, you're asking it to sort of test certain things to destruction to exclude them. And so you're constantly, you're not sort of like generally magnifying everything. You're really focusing in, magnifying out. It kind of looks like the old design thinking double diamond, right? We're going to go out, we're going to go in, we're going to go out and go in.
Yeah. I think it's a good point, because it is about, like, I think that's one of the, and maybe you guys can confirm whether this holds up in sort of the development use case, but in more my, like more like business or strategy use case, it is helpful to help expand, like you said, the double diamond, like to expand my thinking on this. What am I missing? Like attack this idea, right? Even doing like red team, blue team things, like, like really trying to expand out on what I'm doing before I start to focus down in on it. And so does that similar concept show up with you guys in more of the development approach?
So Maximus, one thing that you sort of, I think you introduced us to was one of these ChatGPT instances that sort of is a solutions architect model. And I've used that on a couple of things. I've actually found that incredibly helpful because the prompt is designed to be open-ended, right? Like the prompt always ends with ask a couple of questions. Yeah. And that's really interesting to me. Not because I see it as a replacement for what I do, as such, but it is extremely good at, because of the way that it constantly expands out what it's asking about. it's very good at ensuring that you're sort of hitting all the bases, right? You can get to the point with any kind of solution in that particular prompt where it's asking such very, very specific, detailed questions that you
Yeah.
feel like, okay, I've gotten everything I can out of this.
Yeah.
But, in certain cases, you're looking at a solution and, you're sort of expanding out, and it'll start bringing in parts of the solution that, maybe I locked behind a wall and I'm like, we'll worry about that later. And so I do think that it is very useful. It's also a pitfall, right? I mean, the problem is every time you ask it to expand, it's generating more noise and more chaos. And so it's incumbent upon you as the human being to pick out what's important and get rid of what isn't and bring it back in. So it's a constant battle, at least as I've seen it. And I think this is equally true in like Aider, which is an ask mode, or an architect mode, which is more the open-ended, don't write code, but let's talk about the code. And it is a constant sort of tension between, the AI trying to expand, trying to magnify, versus the human saying, okay, now let's put the attention back on what's important.
Craig, unless you have a different one that you really think would be better, I was thinking, you remember the client we had, where a couple months ago you had kind of done a review of the code and identified some problems with a sort of vibe coded, code base. And then you did a session with a couple of different folks, and the effort was to try to address some of the architecture and security things.
One of the more interesting ones that sort of came in the door, and one of the projects that I think, at least from my point of view, really forced me to reassess AI as a development tool and really, really say, okay, we have to come to grips with this. This is the future. Was this project where the client came in with a, I'll say vibe coded tool, but I'm going to give that some nuance here in a second. Came in with a version of a proposed tool that they had built largely because their search for a development partner had gone on for a very long time. They had really spent a lot of time talking to different studios before they came to us. And while they were doing this, they decided, well, why don't we fire up Cursor and see what happens? These were not computer programmers, but these are very professional people. They operate in a space not dissimilar. And so they brought a lot of both focused domain knowledge and the ability to focus on very specific parts of this application in a way that was much more like the way that a programmer or a computer scientist would tackle the problem. And it was the first time I'd seen a vibe-coded platform come in the door from a client where I'm like, this is actually almost an actionable product. It was really surprising, and for a professional developer, a little terrifying. But it's been an interesting experience too. I think we've learned a lot from that one as it goes forward. One of the things that we've learned from there is, once again, even for somebody who's very disciplined in what they know that they want and very disciplined in how they attack the problems, AI will still generate a lot of stuff on the fringe, right? There's sort of like this, kind of fractal growth of things in the platform that are maybe not, core to the platform and are sort of easy to ignore or skip over. And that's where the QA side has become absolutely invaluable. Our QA lead has exhaustively gone through this platform and built these, very, very detailed descriptions of what is there and what are the flows and what works and what doesn't. And that's really effective because a lot of times AI will happily put stuff in there that it thinks should be there. Not something you asked for, but, if you ask it for a settings panel, it will put a bunch of settings panel type stuff on there. It doesn't know any better. It's not thinking. It's not reasoning. It's dealing with stochastic adjacencies, and a stochastic adjacency is, you should be able to change your password from here. I didn't ask for that. I didn't want that. And yet it's there. And so it's interesting because once again, with human developers, every line of code is precious.
Yeah.
With AI, tokens will be generated in places you didn't expect them to be generated. And so a lot of kind of what we've done with that project has been to carve things away. That's been
Like
interesting
things
because
that were there that are not necessary for launch, right?
exactly, either because they don't work or because it's not necessary for that scope. What going back to kind of what has AI enabled us to do?
Yeah.
It enables us to test hypotheses, put things into market faster than we ever could before.
Mm-hmm.
That doesn't mean that we're necessarily going to save a lot of time getting the final product to market. We don't know
Mm-hmm.
that yet.
Yeah.
And we've talked about this before, right? I mean, the problem in software development is the first 90% of effort gets you 90% of the way there, but the remaining 10% is the second 90% of effort.
That's right.
And I'm not convinced that AI,
Solves that
obviates that.
totally yet. Yeah.
We're not absolved from that problem yet.
Yeah. Yeah. Maybe you just
But
get to 90% faster.
hey, it's a huge thing, and the other thing that I do think that it enables, and I think we've seen that with this particular client, and I think we're going to see it with other clients. This particular client is taking a very, what I would describe as a sophisticated and measured approach to product launch,
Mm-hmm.
which is to define these upfront hypotheses and say, what is the code that I need to build to test this hypothesis? And it becomes sort of an innovation stage gate approach, right? I'm going to figure out, is this what I want? Is this not what I want? What we've already seen is that's enabled them to be so much more agile during this early phase. Agility that normally we would have to encompass within the pure design side, right? You think about a traditional kind of design thinking period, and 6 weeks, 8 weeks, 12 weeks, 14 weeks, right? I mean, these can go on, depending on how complex the project is, for a long period of time because you are testing those hypotheses in the design phase. And what we can do now is we can take those same design-led hypotheses, but we can push them out into the market. We're not, necessarily limited to doing focus groups or scaled qualt or kind of all the traditional tools that we've used in design thinking to act as proxies for the real world. AI lets us iterate so much faster on those hypotheses that we can actually push them out into the real world and see what happens. Exactly. So it's a level of product agility that I think we've just begun to tap. I think there's so much more we can learn from that.
Agreed. I think it's a great approach too. And I think it's funny too, like hearing you talk about that, how much there is a mirror with a lot of what the AI does and how we as humans still do things. As you strip away the complexity and the noise, you can move faster on things and more intentional and more on target. And that's sort of what we were just talking about earlier on in the conversation about simplifying things and getting the AI to focus on specific objectives, specific pieces. So that it's pretty fascinating to sort of see a lot of the parallels that are kind of showing up there as we're doing this. Can you give me like some sort of an actual example where you were going down that path and you looked at it and you're like, okay, it's better for me to flush this and like have it take a fresh crack at it again?
Definitely. One example is a client offered a very simple MVP as well as two screenshots. I'm going to assume that they're wireframed. And one of my tasks was to take that design system, sort of pull it out of, let's say, a screenshot and MVP, and then write it all over again in a code base so that I can work on a much more complete MVP for that client. And not only have I tried to use Cursor and even Claude Code in this sense, and I had to go back and forth with both of them, and even V0 and even Lovable. So I was using multiple tools here, and I was constantly improving the guardrails and the prompting, the spec I gave it. A lot of it had to come with, you could say it was an error-driven development way in that I tried one approach with the prompt, suggestion that the design tokens were X, and then that didn't work. So I tried Y, and that kind of worked, but it needed some enhancement. So then I pushed it towards Z, and it was just generally speaking, being willing to be more pragmatic, being willing to throw away code more than people would usually want to, which is kind of hard to do sometimes. It's kind of scary sometimes. Like you see a perfectly fine code base, as far as like how it generated it, but you know that you can't really push it any further if you don't make these structural improvements. So I think there's probably a lot of discipline. It's just being willing to throw stuff into the trash, even if it seemed fine, just so you can make it better, or being willing to throw away what you think was meaningful progress because it just didn't hit the mark right enough. And so you're willing to start a completely new session where the guardrails and the spec that you have is actually much more polished than before.
Yeah. And a lot of it I think is not just learning the technology, it's a mindset shift is what I'm observing in that in pre AI days or like, in the not too distant past, you invested so much time to code something to get to a certain point, right? And you very rarely would you say, I'm just going to toss this all away and I'm going to rewrite it all again, right? Um, However, when you can get to that same point much more rapidly with an input, again, all the math changes. You may not have nearly as much time invested in this, and in fact, you will be saving a whole lot of time by saying, "Hey, it's better for me to go rework my prompt, rework the guardrails, take another shot at this, toss it away because I learned a lot from its first shot at it." Right? What we're not saying is that you don't go real far down the development path and then toss away a whole code base. That's not what we're saying, right? We're taking small pieces.
Things tend to repeat themselves. So nowadays with spec-driven development with AI-based tools is very similar to domain-driven design from a while ago. You tend to find yourself using the same things. You don't find yourself recreating the wheel all that often, um, which I think is pretty cool. It's that some of these ideas that we've dismissed before are actually right. They just weren't ready for their time yet. And I think as, technology improves over time, things we may have dismissed from years ago, could be approached again.